module in this unit is definition of logarithms, but first we kind of need to talk about, hold on, sorry, I just thought of something. I didn't skip. Huh, okay. I think I rearranged these from the way I did it last semester, sorry. All right, so this is about logarithms, but we got to talk about what a logarithm is. So first of all, we need to know what an exponential equation is. So an exponential function is f of x equals a, I think they say a to the b x. I'm just doing b to the x. Okay. Oh, I'm just doing b to the x right now. So the a in front, remember the a in front is the a in front of every equation. The a is where you multiply. If you multiply by positive, it kind of increases. If you multiply negative, decreases. It opens up, it opens down. So that's what that a is. But just to talk about it right here, I'm going to use f of x equals b to the x. So exponential is where you have the exponent, variable in the exponent. So a variable in the exponent. That is how you identify what an exponential equation is. If we were to rewrite this using like y equals mx plus b, it would be y equals b to the x. Remember, function notation is just a different train of thought there, where you have f of x is an input, and then you get the output. So y equals b to the x. All right, so that's kind of what a logarithm is. I guess I'll say this real quick. I should have had it graph it for me. I just turned my... Let's see if we can turn this back on. See if I can make this work. I haven't used this since they first came out with it. Y equals 2 to the x. Insert graph. Hoo-hoo, look at that. Fancy stuff there, Apple. All right. So y equals 2 to the x, you might have heard of exponential growth, exponential decay, things like that. So this is like an exponential growth equation. We have on this one right here, we have it is positive, so it's going up. We're going to talk more about the graphs later on, so I'm not going to talk too much about that right now. But what I need to focus on is this y equals b to the x, okay? When we did, a long time ago, we did inverses. So the inverse of an exponential. If I were to go to try to solve the inverse, don't write this down if you're writing this stuff down. Remember, you switch the x and the y if you're trying to find the inverse, and then you solve for y. Well, how in the world do I get this y to come down here? Okay, math wasn't invented to torture you. There was usually a reason, right? So I got to figure out how to get this y from the exponent down here somewhere. Technically it'd be down here, but so this is where logarithms came in, and they said, okay, we got to have something to bring that down. So we are going to do logarithms. So what the logarithm does is it brings that exponent down. So using this red one, the inverse of this, and this is how you have to be able to go back and forth between this very well. So the inverse of a exponential is a logarithmic equation. It is going to be log base b of y equals x. So you have to figure out how to rewrite this. This is not a fun way to do it. The way that I do it, the way that I just did it in my head, just to make sure I was right, since it's 8 a.m. after a long weekend. Base b, this is called the base. Like when you're talking about this is the base, this is the exponent, right? So you say log base b. This is a little b that goes right here on the log. So it's a very little b that goes right here. And then the way that I say it is that, or the way I remember which are the x or the y, is that since this exponent is up here all by itself, it is going to go over here by itself, okay? So what actually happens here, and probably the better way to write this is, sorry, this is why I think I just figured this out. I taught this for 12, 15, 20 years. I don't know how long I've taught this, and I just figured out why I always get my letters mixed up. So if we were doing the inverse of the exponential, we'd say, how did I write that? It was x equals b to the y, right? Okay. I'm trying to figure out how to get that y down. So I would say y is up here by itself, so it goes over here by itself, log base b of x. Okay. So I just kind of rewrote that a different way. this is the logarithm of this one right here. Right here, okay? The one I had, the red one that I just wrote a second ago, was the logarithmic of this. Sorry, I know I switched that x and the y on you, and my bad. But I just thought about that. I just like it when it's y equals. Just like y equals mx plus b, it's always better when it's y equals. So what I actually did is this is the logarithm of this. Just a second ago, I did the logarithm of this one, okay? My bad. This makes more sense to my head, though, okay? So this logarithmic, you have to figure out, again, how whatever works. I've had people do 1, 2, 3 and 2, 3, 1 or 3, 2, 1, whatever it is. So like label them 1, 2, 3, and then down here it's going to be, 3, 2, 1, okay? I've had people do it like that. So whatever helps. The way that I do it, the exponent's up here by itself, so the exponent goes over here by itself. So there will be a lot of back and forth. The graph, if you remember anything about the graph of, let's see if Apple will do it for me again. No, where did it go? I was really hoping it would. It doesn't like log, probably. That's sad. I'm going to try to write it one more time, see if Apple will do it. Y equals log base 2 of x. That's sad. I wonder if I can do this. Edit. Ooh. Can I draw on it? Okay. So the exponential, if you remember, what happens here is they are... I can't draw on it either. Man, we tried. Okay. All right, so the exponential one that we have drawn over here, it goes through the point 0, 1. Okay. It goes through the point 0, 1. We'll talk more about the graphs probably next time. But if you remember inverses, they are always symmetric across the line y equals x. And you flip the point. So if that's 0, 1, then we would do 1, 0. So this one actually goes like this. And it goes through the point 1, 0. All right. So that's kind of the basics of the logarithm. Now let's go do it a bunch because we're gonna go back and forth a bunch. The very first topic is, please don't sign me out. The very first one is like using a calculator. We won't use this much. Oh man, it already has ln. I'm coming back to ln, so I'll come back and do that one. All right, so going back and forth, 4, -3, 164. No, Apple, calm it down. No, I need to turn that off. You didn't make the graph for log, so we're done with you. Log 661, okay. Okay, so you see that little one right here on this one, the log base 6. It's a little 6 down there. Log base 6 of 6 equals 1 is how you say that. These are not super difficult. You just have to figure out how to do this part right here, and you'll be okay in this section. So what we're going to do is, first of all, go from exponential to log. So the way that I would do it is I would say log base. My base is my base of the exponent. Log base 4. The exponent's up there by itself, so it goes over here by itself. Of 1 over 64. So all I'm doing is rewriting this. We'll talk about what it's actually doing in just a second. What it's at, well, I can say it on this next one. On the next one, what a log actually asks is, says, my base, this to what power gives me 6? 6 to what number, 6 to what power is 6? And the answer is 1. 6 to the first power is 1. But all we're doing right now is rewriting it. So I do base 6, my base 6. The exponent is over here by itself. So I write the exponent up there by itself, and it equals 6. Okay. We have to be very good at going back and forth on these because it just makes life so much easier. 6 -2, 136. Log, what was it? Oops. Go away. 464.3. Okay, so on this one, we do log base 6. The exponent's up there by itself, so it goes over here by itself of 1 over 36. Okay. On this one, we do base 4 to the third power is 64. If we did not have this number right here, a log is saying what number, 4 to what number is 64. But if you've got to get used to doing this first, well, you can rewrite it with an x, and we'll talk about that in just a second. Kind of skipping around on topics here, but there's a certain order I want to go in before I get to that natural logarithm. Log 2 to the 1/2. Well, they're making it hard to start. All right, how to actually solve logarithms. Let me write some hard ones out here. Let's get some log. What was the one they had? 2 to the 1/2? Oh, not that one. Well, we could do that one. That's fine. Let's do one more here. Log. Okay. Log base 7 to the 49th power, okay? If you need to, this is saying 7 to what power is 49. This is saying 7 to what power is 49. If you need to put equal x to try to figure out what this is and rewrite it, that is fine. This is going to say 7 to what power is 49. If you want to do that, just as you get used to these, that's fine. So y'all can answer this, 7 to what power is 49? So my answer is just 2, okay? 7 squared is 49. 7 to the second power, 7 times 7 is 49, okay? So this is saying 2 to what power is 16? Again, if you want to rewrite this with an x, you can say 2 to what power is 16. It does not hurt to do that until you get used to what a log is. But it's saying 2 to what power is 16? This would be, what, 2 times 2 times 2 is 8, times 2 more is 16. So it would be 4. 4 would be my answer. Okay. What about this one? Anybody know the answer to this one? 5 to what power is 1 to the 25th? 1 over 25. -2. It would be -2, right? Because 5 squared is 25, and 5 to the -2, to get rid of the negative, you drop it underneath, right? So then anytime you see a fraction, you might have a negative, so don't forget your kind of exponent rules here. So then this one is saying 2 to what power is 1/2? -1, correct. 2 to the -1 would be 1 over 2, because you drop it down. Here's a harder one. And this is where it does help to like write it out. 16 to what power is 4? What? 1/2. Yes, somebody said it fast. 1/2 is the answer. Just to walk through that real quick, you're saying 16 to what power is 4? 1/2 is the same thing as square root. 16 to the 1/2 is the same thing as the square root of 16. So it is possible that you can get a fraction there. Sorry, I was trying to think of something there. It is possible to get a fraction there. I think we'll save that for next time. All right. So every one we've done so far has a base. This one does not have a base number right here. Okay? This one does not have a base number right there. It defaults to a 10. So anytime there is not a number there, it is 10. So this is saying 10 to what power is 100? So if there is no base, think base 10. So this is x equals 2. If no base, then it's 10, okay? So this is 2, okay? So the answer to this is 2. 10 squared is 100. So if there is no base, it is 100. All right. So let's go back to this one. In exponential world, they have what they call the number e. It is like 2.71, 2.72 if I round it. 2.72, it has to do with some calculus a little bit, but this is kind of like pi. You know, pi is, the symbol pi is 3.1415926, kind of keeps going, but we use 3.14 for it. The number e is kind of the same idea here. The pi is the ratio of the area of a circle to its radius squared, whereas the number e is like a limit, which is a calculus thing, and it talks about the rate at which it gains. Try not to go too much in the calculus there, but so it is just like a number e right there. So what happens here is if I have log base e, you use this e a lot in like exponential formulas and things like that, so it does have a lot of properties to it. But if I had log base e of some number, I don't know, we'll do 2.72 because I know that's 1. Log base e, okay? We don't write log base e. What we do is what we call the natural logarithm. The natural logarithm, or natural log, is called the ln. I don't know why they write it backwards, but they do. ln. So the ln of 2.72 would be 1. The ln, the natural log, has a base of e. So this is like base e. So this would be e to the first power is 2.72. Okay, you don't write it, just like the log 10, you don't write it, but it is there. All right, let's go to this topic first. ln x equals 7, ey equals 2. All right, so the ln of x equals 7, so this is just converting back and forth. So remember, if you see ln, it just means base e. So this would be base e, exponent's the one that's over there by itself, equals x. E to the 7th is equal to x, okay? Which you just have to use a calculator to solve this. On this one, when you see base e, you automatically think ln. So I do ln base e. I don't have to write the base e. Exponent is over there by itself. And then 2. So ln of 2 equals y. So you do not have to write base e. It's actually incorrect to write base e. It'd be ln of 2 equal y. So the ln always has a base of e. But it works, everything works the same exact way. Okay. To solve the ln's, since it is a decimal, you can just use a calculator. So they have these problems right here on Alex. Your phone even has the ln button, I think, on it. So you would just do the ln of the square root of 11. Y'all want a bunch of these on the test, right? Ln of the square root of 11 is 1.19, okay? 1.199, I guess, if I just round to the nearest thousandths. And then the log, I could do log 29.6. So you just type those in. Very easy topic to do there. All right. The last topic here is the change of base topic. I just really want, there, that's fine. Log base 5 of 3. On this last one, it is called the change of base formula. If I have log base 5 of 3, so even if I put an equal x here and I say, okay, 5 to what power is 3? Well, that's not one of those easy numbers. It's not like 25 where we know it's squared. 5 squared is 25. 5 to the first is 5. It's not a number, like we don't know. So it is, all right, x is some decimal, okay? So what they do is they call the change of base formula. And what this allows us to do, a lot of calculators now, you can change the base in the formula. Like you can change it on your calculator. And if you want to show me your calculator, I can see if it does that. But you used to not be able to. So the change of base, what you do, and this is a bad way of writing this, but you take the log of the big number divided by the log of the base. Now, what I mean by big is that this number is bigger in size, not quantity. Like, okay, you take log of the big number divided by log of the small number. So if you ever get stuck, you can do this. The log of the big number divided by the log of the base. So this one is just going to be some decimal that we can't figure out. Even if you have log base 7 to 343, like that's hard to do in your head. Maybe you don't know that 7 cubed is 343, so you can do it in there. So like what I do is I do log base 3 divided by, log of 3 divided by log of 5. In this calculator, I can't change the base of log, so using this formula automatically changes it for me. Okay. So you can always check your answer. I mean, technically you can do anything like log 25 divided by log of 5. This is saying 5 to what power is 25? Well, it should be 2. So you can always get your answer in the calculator by doing log of the big number divided by log of the small number of the base. I'm going to screenshot that real quick. I want to do one more I just thought of. I don't know if we'll run into this, but I want to go back up to this topic. Real quick before we leave this section, let me just talk about one other thing that may be helpful. Log base 8 of 8. Anybody know the answer? This is saying 8 to what power is 8? 1, right? So if you need to write it out, you say 8 to what power is 8. My answer is just 1. Okay, so when these numbers are the same, your answer is always going to be 1 because it's saying what number to what power is 1. So like it should be quick to do. Log base 25 of 25. My answer is 1. Okay. The other kind of like weird one that they do is log. I think 7. Oh no. 1. Not 0. Log base 7 to the first power. So 7 to what power gives me 1? This is saying 7 to what power gives me, I just wrote the answer. Whoops. 7 to the 0 power equals 1. I meant to write an X and I wrote a 0. So 7 to the 0 power, anything to the 0 power is 1. So anytime this is a 1, you always get an answer of 0. This is saying 258 to the 0 power. Anything to the 0 power is 1. Okay, so there's just some like different ones that are odd. My point of saying this is that you can never, and I'll write this right here, I think we'll run into it more often later on, can never do the log of 0 or a negative. There is no way that you can take something to a power and get a 0 or a negative number, okay? Or you can't do the log. You can't do something to a power and get a negative number. Yeah, that's right. So like if I had log of x, x always has to be greater than 0. That's the way I say that. All right.